Hey everybody, this is an introductory lesson to get you started on hands-on equations. This is just a system that allows you to get really comfortable with variables, understanding how to solve equations with an unknown when we're using a letter for that. And it also begins to work quite a bit with concepts of negativity, negation. Some of the things that we're working with in AOPS that can be a little bit better understood if you're doing it with pawns and dice, okay? And it can be a little bit more fun. So those of you who are local, you'll have a kit. Those of you who are following along remotely, you'll have to kind of do this a little bit more pictorially, but it is something that I found beneficial for everybody in my pre-algebra classes to do. You will be forwarded to some links for some of the lessons in here that are taught by various teachers. Some teachers actually begin this as early as 4th grade. You can do that. You have to go rather slowly. What we're going to do is we're going to work through this a lot quicker is how we're going to go about it. Plus, I'm going to use the big words, okay? I'm going to actually use the words that you're using in AOPS, the definitions, versus kind of making it a simpler, for a 4th grader. You guys aren't 4th graders, okay? So anyway, it has a lot of value, and I think you'll find that as you go through this. So it's built on an extremely simple concept, and that is that we think of an equation as a balance beam, okay? So it's kind of like this is our equal sign. And the most simple equation of all is if I have something on the left side, right? And if I have a weight, if you want to think of it that way, on the right, well, if this is 2 and I've got one weight over here, for it to be in balance, this must be 2, right? And in fact, if I have 2 weights over here and it's in balance, well, these 2 have to be 2, therefore each of these has to be 1. And it really is as simple as that. And then we're going to start working how in algebra it is as simple as that too, only we stop using pawns and we start using X's and letters for that, okay? So lesson 1 is extremely simple. You guys could actually probably figure a lot of these out, but it's really just to kind of see it and see how it works, that if I have 2 pawns over here, and the pawns always stand for an unknown. They stand for variables. We're going to start using X for that, and they're called variables because they can vary, they can change. So they don't ever necessarily equal the same thing from equation to equation. It's going to depend on what's on the dice. So if I have a 10 here, well, of course, that's the same as having 2 5s, which of course would mean that each one of these would have to be 5. And the other way to think about it is it's just going to be 10 divided by 2 to spread it evenly between the 2 pawns. Okay, so over here, what we'd say, I just modeled this here, but if I have these 2 pawns, right, and they're equal to 10, well, then each one must be 5, and we would just say X is equal to 5, because 5 plus 5 is 10, and 10 equals 10, okay? Super simple. And over here, like, let's just say that I have, this is the second one here, if I have the 10, and some of you are going to catch on to this totally if you haven't already. This is not hard, but again, it's new, so we're going to take our time to actually make sure we understand it. What we're really thinking is 2 plus what weight would balance out a 9 weight, right? And I guess another way I could have looked at this is that 9 is the same as 7 and 2, right? Okay, so if these are the 2's, the pawn must be a 7, okay? So that's kind of it's like our mystery weight in these little equations, okay? If you look at number 3, I've got 2 pawns, I've got a 3, and then I have a 7 over here, okay? And I could simply think, what plus 3 is 7? Well, that would be 4 plus 3 is 7. If these are 4 together, then each one must be 2, right? Another strategy, and you're going to find this is what we call a legal move in the next lesson, is I could look at that 7 as, well, I'm going to have to get another die here because I'm out of my little ones there. Hold on one second. And let me see if I can find another little one. There we go. So I'm going to treat this as if this is 3 plus 4, and this is 3 plus my pawns, okay? Well, if you notice that if this is imbalanced, then if I take the same amount off of each side, it's going to still be in balance, right? If I removed 3 from each side, and then it's really easy to see that these 2 pawns have to equal 4. Therefore, each one of these must equal 2. I'm dividing the 4 between the 2, okay? So in that case, my x would equal 2. You could even, over here, you could write it, well, 2 plus 2 plus 3 does equal 7. That's essentially your checks, okay? All right, so you can just kind of play around with this. I'll have a solution up if you would like. I've usually done this in class, but with the holiday and the way that the year has started, I'm going to actually have you just kind of introduce yourself to this in the lesson this week. And I'm going to move on to the next page, which would be lesson 2. And this is where, instead of using the little picture of a pawn, we're now going to call the pawn an x, okay? And when we put 2x, what we mean is 2 times x, or 2 x's, okay? That's kind of how you interpret that. Now you see why we stop using the times symbol, because what would be 2xx would be very confusing, right? But if we see a 2 in front of the x, then we know that we have 2 x's. That's what that means. That's what I have on the left. The equal sign is my bar. Then I have 1 x on the right, and I have a 3 on the right, okay? So again, probably the easiest, you could really actually see this, right? That, again, I think the easiest way to look at this is, well, why don't I just take the same thing off of each side, right? And still stay in balance. Obviously, the x has to be a 3, okay? And then if you think about it, if I put them back, right? Well, if each x is 3, 3 plus 3 is 6, and 3 plus 3 is 6. So the check part would be that the 6 equals 6. If I put everything back on the balance, I've got 6 equals 6. Okay? All right, and then I'm going to do 3x means 3 x's. Okay, 3 of these x's, and those are my mystery pawns. It could be something different every time. And then I have 1x over here and a 4. Okay? Some of you would immediately be able to see this, but the easiest way, in my opinion, is I always there's a strategy if you hadn't noticed. I want to get the dice all by itself on one side and the pawns all by themselves on the other. So I am going to remove these 2 pawns from each side because I'm still in balance. And then I can see that I've got the 4 split between 2 pawns. Each pawn must be 2. Check it by putting it back. And I have 3 of these x's. That's 3 times 2 is 6. 2 plus 4 is 6. And again, 6 is equal to 6. The check is the same, even though the x is a different amount. Okay. The third one's just slightly different in that I've got an x and a 4. I've got dice on both sides here. Then I got 2 x's and a 3 here. Okay. So I have a couple of options. It might be easiest just to do what I did before, right? I could just say, well, I could take something off of both sides. And I don't know, that makes it pretty easy to see. If there's 4 on this side, and 3 plus something equals 4, the something has to be 1, right? Okay. And let's go back and check. Well, yeah, 1 plus 4 is 5. 3 plus 1 plus 1 is 5. 5 is equal to 5. Okay. All right. So that's the second lesson. Okay. We're just going to, I usually go through about 3 to 4 lessons the first, because you guys are an older group and usually can catch on to this pretty quickly. But if it feels a little bit fast to you, this is in a video. You can go back and replay any part of this over again and practice. Okay. So this is on lesson 3. And so now I'm going to do 3 x's on the left and a 7. Okay, whenever I have 3 in front of the x's means I have 3 of those x's. If I have a number, it's a number all by itself. It's what we would call a constant. It does not change. And then I've got 4 x's on the right. Okay, well, I think so far I've only been dealing with like taking one off at a time, and I could do that. I could say, well, I could take off one off of each, and one off of each, oh, and one off of each. Or I could recognize that my strategy is to get this guy all by itself, so might as well just take 3 off of each side. And lo and behold, what does that pawn have to be? The pawn has to equal a 7. Our x is equal to 7. Notice, it doesn't matter which side is in. I could say 7 is equal to x, or I could have said x is equal to 7. They mean the same thing, okay? This x doesn't have to be on the left-hand side. Let's go back and check it. Well, if x is 7, then what I should have on the left is 4 times 7, right? 28. And this should be 4 times 7, 28. Easy enough. 28 is equal to 28. There's my check. Okay? You notice they start to get a little bit more complex, if you will. So I have an x, I have a 2, this is number 2, and then it asks me to put up 2 more x's, and then I have an x, and I have 10. Okay? All right. Now, I do want you to notice we're going to start talking about combining like terms. It's a really important idea in algebra. And what it says is that if I have one of the same thing here, and then I'm adding something, and then I have 2 more of the same thing, well, I could just kind of combine all those things together, look at them as their own little group. So if you notice over here, I could have combined the x and the 2 x's and look at them as just 3 x's. So this would be the same as 3 x's plus 2, okay? Now I'm going to look at my strategy like, okay, this is a bigger number. I think I'm just going to go at least try that. Okay, so I have 2 of something plus 2 is equal to 8. Logically, okay, if this balances out, then these 2 here have to equal 8. I said 8 because I had 8 in my mind. If they were equal 10, right? So 8 plus 2 is 10. But even easier is to take 2 away from the 10, and it's even easier to see. Let's just say I'm going to treat my 10 as if it's 8 plus 2, okay? So I took the pawns off before. I can take the 2's off too, all right? 2's off also. And now it's just really easy to see that each of these pawns must be 4 because they balance together. They balance out the 8. So I'm going to put a 4 here, okay? And now I'm going to put everything back the way it was. Remember, I had 3 x's plus a 2, and then I had an x plus a 10, and I'm going to double check, okay? If I'm right, the left-hand side and the right-hand side should balance. So if x is equal to 4, well, I'd have 3 times 4, 12, plus 2 is 14. 10 plus 4 is 14. Check. 14 does equal 14. All right? So we are doing algebra here. This is balancing and solving algebraic equations. They're pretty simple. There's some pretty complicated ones as we move up in the lessons, but I have had I've never run across a student who couldn't do them, especially when they're able to solve them this way. Okay? All right. So again, I'm going to think about this number 3. I've got 1 x, but I've got 3 more x's. So notice I really have 4 x's on my left-hand side. And then it tells me I've got 2 x's on the right and a 10. And hopefully you're seeing that right away I want to get rid of my double x's to get this by itself, which makes it super easy to see, right? That each of these pawns must be a 5. 10 divided by 2. And then I'm going to put those all back and double check. 5 times 4 is 20. 10 plus 10 is 20. 20 is equal to 20. Okay? So I'll leave you to have some fun workout number 4. All right? And then lesson 4 is all it really does is increase the size of the numbers. All you're doing is following exactly that same logic. I think I'm just going to do 1. There's really nothing new to learn here. Other than they just begin to look a little bit more complicated. I'm going to do number 2 here. All right, so, but I'm just going to go methodically. X plus 2 more x's plus 14. That means I'm going to need to use 2 of my dice. And then on the left side, and then I've got 5 x's. 1, 2, 3, 4, 5. And a number 2 on the right. Okay, so again, just a little bit more going on, but I notice I have my bigger number over here, so this is where I'm going to want to take these guys off. If I take 3 off on the left-hand side, golden rule of equations and balanced beams are, if I want to stay in balance, whatever I do to the left side, I have to do to the right side. Okay, so I'm almost there. Some of you could probably see the answer, but I could make my life a little bit easier here. If I think of my 14 this way, okay, as 12 and 2, right? In which case you could see that if I pull that 2 off of each side, the 2 pawns equal 12, therefore each pawn is equal to 6, right? Okay. To get the check, we have to put everything back. And if you notice, I'm kind of staying organized and leaving everything down here because it's just easier to put it back. Unless if I throw everything up there, then I got to hunt for it again. Okay, so we're going to treat every x as if it is a 6. So 6 times 3 is 18, and then we'll call that a 20. 32. Okay, so I've got 32 on this side. And then 6 times 1, 2, 3, 4, 5 is 30, plus 2 is 32. 32 is equal to 32. And you always do this check because people do make mistakes. As these become a little bit more complicated, we are going to start mixing in negative x's and negative numbers. The checks, just make sure you didn't make a mistake. If you have a left side not equal to the right side, then you did something wrong somewhere, and you need to take a look and redo the problem and see if you can figure out where you went wrong. Okay? All right. I'm going to go to one that has subtraction. This is lesson 5. Okay, and if you notice, each lesson has 4 new problems, and then what it does is has a previous work section where they just have similar problems to the previous ones. Some of that's going to be kind of, I'm not going to do a lot of these, the real simple lessons up at the front. But as we move up in lessons, you'll probably want to do more and more of these. I'll be assigning some of these to get that practice in. Okay, we're going to go with number 1 from left to right. It says I've got 4 x's. Okay, 1, 2, 3, 4. Now it says minus 2 x's. Well, that just means subtract 2 x's. Okay, then add a 4. Okay, that's my left side is done. Now my right side equals, I have an x and there's a 10, okay? Well, now if you look at this, this isn't that bad. It's very similar to ones we've done before. I'm going to take 1 off on each side. What plus 4 is 10? Got to be a 6, right? Put them back to check. Well, 6 and 6 is 12, plus 4 is 16, 6 and 10 is 16. 16, in fact, is equal to 16, okay? All right, so it's really that simple. Some of you are going to get to this point where you may or may not need to use the pawns. I could think, if you look at number 2, I have an x, 1x, right? 1x, plus 3 more x's, minus an x, okay? What you actually, now that we've covered negation, what you may have noticed is I have a positive x and I have a negative x, and those cancel each other out, leaving me with just 3 x's, okay? So I don't really have to show positive x, 3x, take away an x. I could actually notice that these two negate each other. And you could notice, look on number 4, I have the same thing. I have, if there's no plus in front of it, it's a positive. I have a positive x and I have a negative x. So I don't have to go from left to right. I can just simply negate anything that's a positive and a negative. And what am I going to have? I'm going to have 2 x's. I'm on number 4 now. 2 x's, right? And I've got a 7 is equal to, sometimes the hardest part can be finding the right place there. 4x's minus an x, well, that'd be 3x's, right? 4x's minus an x plus a 2. Okay, and here we go. Knock off 2 on each side. Oh, but plus 2 is 7, must be 5. Let's see, I think I was doing this one. Let's see. So I'm going to go back. I'm going to put everything back, right? This was my original problem. If x is 5, 17, right? 5 and 5 is 10 plus 7. 15 plus 2 is 17. We have 17 equal to 17. Okay? So that is through lesson 5. And I'm going to go ahead and do lesson 6 here, since I think you guys can handle this. We've already talked a little bit about a property called distribution. And so we're going to think about what it means if I have these parentheses here, right? If I have an x plus a 3, I like to think of parentheses here like a pocket, okay? So it's like I have an x plus a 3 here. But now I want the 2 here means double that. So I want 2 x's, so I'm going to multiply the x's times 2, and I want 2 3's, which I could also have put in as a 6. But I think this makes it really clear that I have x plus 3 twice, right? Okay, so that's my doubling. What we're going to be doing without the dice, of course, is saying I've got 2 x's and 2 3's. That's what's on the left. Then I've got a 10 on the right, okay? Now here, I don't have any pawns to take off of each side, so I could be thinking, I'm going to turn my 2 3's into a 6, okay? I could be thinking to myself, well, what plus 6 is 10? 4 plus 6 is 10. These each have to be 2's. Or I could make my life really simple by saying, well, 10 is the same as 6 plus 4, right? If I take away the 6, I can see that each one of these has to be a 2, okay? So I'm going to say that x is equal to a 2, and I'm going to put everything back. This was a 10, right? And if it's a 2, 2 plus 2 is 4 plus 6 is 10. Yeah, everything checks. 10 is equal to 10. And notice if all I ever have is an equal to something over there, that's what I'm going to have there. Okay, at this point, I'm going to turn you guys loose to do a few more of these on your own at home, and we will be picking up from here in class. And I have a few video lessons that you can also look at if you want to go a little bit further with this on your own. Do a little bit of practice, get yourself comfortable with the idea that the pawns here stand for x's, which could be any number. It just is going to depend what we end up isolating on the other side, right? And we will pick up from there. I'll see you in class.